Hi, good morning. Welcome to my channel. In this lesson, we want to discuss a geometric mean or sum of nth term of a geometric series and sum to infinity of a geometric series. So if you have not subscribed to this channel, please click the subscription button below. So at the end of this lesson, you should be able to solve problem on geometric mean. Okay. 2. Or find the nth term of a geometric progression. The sum of the nth term of a GP. And 3, you should be able to find the sum to infinity of a GP. So let us start as we continue the lesson. Now when we talk of geometric mean, what do we mean by geometric mean? Okay, if you have 3 terms, a geometric sequence ABC, you know the common ratio is obtained by dividing of the second term by the first term, the third term by the second term, and so on and so forth. Okay, so we can find the middle term, which is called the geometric mean. Okay, so this is what we mean. Suppose you have suppose A, B, C are consecutive terms of a geometric sequence, are consecutive terms of a GP, right, with common ratio R, then if we have the 3 terms this way, R equals to B over A and R is also equal to C over A. Let's call this equation 1, equation 2. So if you equate 1 and 2, if you equate equation 1 and 2, of course we have B over A equals to C over A. This should be B. Okay, this is C over B. This is C over B. Okay, so if you cross multiply, we have B squared equals to AC. Okay, and taking the square root of both sides, the square root of B squared equals to square root of AC. Okay, so which implies that B equals to square root of AC. Okay, and this expression in the square root, so therefore the term B equals to square root of AC is called the geometric mean. Of the sequence or ABC. Okay, so this is how to find geometric mean. You can use it to solve problem. You can also use it to insert a number of sequence within a geometric sequence. Okay, so let's consider these examples. Example 1. Insert two geometric mean between 12 and 324. Insert two geometric mean between 12 and 324. So what we are going to do is let the sequence be, let the geometric mean be, let's say A and B. Okay, so the sequence will be 12, A, B, and 324. Okay, so we can find the common ratio. Of course, the last term equals to 324. Okay, and the formula for the last term for a GP, you know, the formula is AR raised to power n minus 1. Okay, so we have just 4 terms in this sequence. We have just 4 terms. We have 12, we have A, we have B, we have 324. So the last term is U4. L equals to U4, which is AR 4 minus 1, which is 3. Okay, so we can say AR raised to power 3 equals to 324, and the first term, which is A, equals to 12. So if we divide this, we have AR3, let's call this equation 1, equation 2. So 1 divided by 2 will give us this, over A equals to 324 all over 12. So A goes in A here. We have 12 in 4 in 12, we have 3, 4 in 32 is 8, and 4 in 4 is 1. So 3 here is 1, 3 in 8 is 2, 3 times 2 is 6 in 21, 3 in 21 is 27. So R cube equals to 27, and of course, taking the square root of both sides, we have cube root of both sides rather. Cube root of R cube equals to cube root of 27. Okay, so cube and cube root will cancel each other, so we have R equals to 3. So the common ratio of the sequence is 3. So from here we can generate A and B. You know, first term, which is A, equals to 12. The second term, U2, equals to AR, which is 12 times 3, which is 36. The third term, U3, is AR squared, which is 12 times 3 squared, which is of course 12 times 9, and which is 9 times 2 is 18, carry 1, 9 times 1 plus, which is 108. So A equals to 36 and B equals to 108. So the two geometric sequence that we are inserting is 36 and 108. Okay, 36 and 108. So that is how to work with a geometric mean. Okay, geometric mean. Now the next outline says sum of nth term of a geometric progression. Sum of nth term of a geometric progression. So how can we find the sum of nth term of a geometric progression? Sum of nth term of a GP can be written in that form. Okay, let us state this theorem. So the sum of nth term of a GP can be written as Sn equal to A into 1 minus R raised to power n all over 1 minus R, and this here R is not equals to 1 and R is less than 1. Okay, so when R is less than 1, use this formula. So we use this formula use this formula when r is greater than -1 and less than 1. Okay, so that is when to use this formula. Now when r is not greater than -1 and less than 1, we have another formula we can use. So we use xn equals to a into r raised to power n minus 1 all over r minus 1. Remember, r is not equal to 1. Okay, so when r is not, use this formula when r is greater than 1. That is when to use this formula simply. So we can prove the formula thus. Now remember, we have the following: u1 is a, u2 for a geometric sequence, u1 is a, u2 is ar, u3 is ar squared up to un, which is ar raised to power n minus 1, where a is the first term and r is the common ratio. Okay, so then if we add all of this together, if we add them together, we have a Sn, sum of nth term. So therefore Sn equal to a plus ar plus ar squared plus dot 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 plus up to ar raised to power n minus 1. Then the second one, we have rsn, that is multiply sn by r. So rsn will give us what we call ar plus ar squared plus ar cubed plus up to ar raised to power n minus 1 plus 1, so which is simply arn. Okay, so arn. Now let's call this equation 1 and call this equation 2. Okay, so if we subtract equation 2 from equation 1, which is equation 1 minus equation 2, we have Sn minus rsn equal to this will be a minus ar minus ar squared up to like that. Okay, so if we subtract, we are going to have this will cancel this, this will cancel this. Okay, this will cancel some arbitrary one here, yeah, and this will also cancel some here around here. So what we will basically have is this and this term from the first term. So and that will give us a minus ar here. That will not cancel. So this will, there are some terms here that will cancel this one, but no term will cancel that one. This one will go, so we'll be left with this and this. So I'm bringing that together, we have a minus ar raised to power n, which is also a into 1 minus r raised to power n. So that means our Sn into 1 minus r equals to this. So dividing both sides by 1 minus r, we have a into 1 minus r raised to power n over 1 minus r, and this is the formula. Okay, so if we want to generate the other one, to generate the second formula, we subtract equation 1 from equation 2 instead. So if we subtract equation 1 from 2, we are going to have rsn minus sn equal to arn minus a, and of course this is a into r raised to power n minus 1. So this is r into xn into r minus 1, and dividing both sides by r minus 1, we have the formula Sn equals to a into r raised to power n minus 1 over r minus 1 to be the second formula. So remember, you use this formula when r is greater than 1 and use this formula when r is less than 1. So this is the formula for finding the nth term, the sum of the nth term of a geometric progression. So let us consider examples. Now, the first and the second term of a GPA, let's call this example 1, of a geometric progression are 4 and 12 respectively. Find the sum of the first 10 terms. Okay, the first and the second term of a geometric progression are 4 and 12 respectively. Find the sum of the first 10 terms. Okay, so from the statement we have here, we have u1 equals to a and u2 equal to ar, and of course, we generate this formula from un, the nth term, which is ar raised to the power n minus 1. Now, the first term a is 4 and the second term ar is 12. So call this 1, call this 2. If we divide 2 by 1, we have ar over a equals to 12 over 4, and a will cancel a here, 4 here, 3. So r equals to 3. Okay, the common ratio is 3. Find the sum of the first 10 terms. So with n equals to 10 here. So remember the formula, since our r equals to 3, which is greater than 1, we use the second formula, Sn equal to a into r raised to power n minus 1 all over r minus 1. Okay, so n equals to 10, so we are looking for sum of the nth term. So a is 4, r is 3 raised to power 10 minus 1 all over 3 minus 1. Okay, and we can use calculator to simplify that. We can leave our answer that way. So this is 4 into 3 raised to power 10 minus 1 all over 3 minus 1, which is 2, 2 here 1, 2 here 2. So that becomes 2 into 3 raised to power 10 minus 1. Okay, and you can simplify that if you have a calculator, but you can leave your answer like that. Example 2. Example 2. The fourth term of a geometric progression is 9 times the sixth term. The fourth step of a geometric progression is 9 times the sixth term. The fifth term is 3 and r is greater than 0. Find the sum of the first 6 terms. The fourth term, let us take the nth term. un equals to the nth term, which is ar raised to the power n minus 1. So the fourth term u4 equals to ar cubed. Okay, it's 9 times the sixth term, and the sixth term, which is u6, is ar raised to the power 5. Okay, so now we said the fourth term equals to 9 times sixth term. So ar cubed equals to 9 multiplied by ar5. Okay, so we can, this is what we have here. If we divide both sides by a, you can have this. Dividing both sides by r also will give us 2. So 9r squared equals to 1. So r squared equals to 1 over 9. Okay, then r equals to square root of 1 over 9, which is 1 over 3. So r is 1 over 3. Now the fifth term is 3. The fifth term, u5, equals to ar4, and ar4 equals to 3. Okay, they already said r is greater than 0, and of course r is 1 over 3, which is greater than 0. Find the sum of the first system. So we need to find A using this formula. So if we substitute R here, we have 1 over 3 raised to power 4 equals to 3. Okay, A times 1 over 3 raised to power 4 equals to 3. So A equals to 3 times 3 raised to power 4, which is 3 raised to power 5. So A equal to 2 raised to power 5 is 243. Now we are looking for sum of the first 6 terms. N equals to 6. Okay, so Sn, since R is greater than 0, and of course R is greater than 0 but is less than 1, so we use the first formula. Sn equals to A into 1 minus R raised to power n all over 1 minus R. So this is the formula we are using, and that will give us something like, so we have Sn equal to, or A, which is 243 into 1 minus 1 over 3 raised to power 6. We are looking for x6 all over 1 minus 1 over 3. Okay, so this can be written as 243 3 raised to power 6 is 3 raised to power 6. That should be 243 times 3, which is 9 to 729. Okay, 243 into 1 minus 1 over 729 all over 3 minus 1 all over 3, and this is the same thing as 1 minus 1 over 729. So this is 1 minus 7 over 729. This is a kind of complex calculation. This is 729 minus 1 all over 729, everything divided by 2 over 3. Okay, so what we will have there is this number 243 into 728 over 729 multiplied by 3 over 2. Okay, 3 here 1, 3 in 7 we have 2, 3 in 12 4, 3, 2 here 1, 2 in 7 we have 3, 3 in 12 we have 6, and this is 4. So what we have there, guys, so 243 here, we cancel 243 there. Yeah. So this 243 we cancel this 243, and then we have 364. So therefore x6 equals to 364, and then we are done with the example. Very easy and straightforward, isn't it? Another example. A geometric series has sum of first term to be 2, sum of second term to be 8. Find the first term you want and the common ratio R. Okay, let's start with A. S1 is 2, and then U1 equals to A, so sum of S1 equal to U1, which is 2, of course. Yeah, that one is obvious. So S2 equals to A plus AR, okay, which is 8. So we have that A to be 2, so 2 plus 2R equals to 8. So 2R equals to 8 minus 6, 2R equal to 4, and dividing both sides by 2, we have 4 over 2, and 2 goes in 2, we have 2, so R equals to 2. Okay, so we find the first term and the common ratio. So therefore first term equal to 2 and the common ratio equal to 2 as well. Now B, find the sum of the first 10 terms of the series. Okay, so we are looking for the first test of S10, n equals to 10. Of course, look at our common ratio, which is 2, which is greater than 1. So we use the formula Sn equal to A into r raised to power n minus 1 all over r minus 1. That is the formula we are using. So if we substitute what we have into this formula, what we'll have there is S10 equal to A, which is 2, into 2 raised to power 10 minus 1 all over 2 minus 1. Okay, and that of course is 2 into 2 raised to power 10. Raised to power 10 is 1024. Yeah, 1024 minus 1, and this is 2 into 1023, and if we multiply this by 2, we have 2 times 3 6 times 2 4 0 2. So therefore sum of the first 10 terms is 2046, and that solves the problem. Example 4, find the sum of this series. It's a GP. Okay, how do we know it's a GP? For A is the square of some kind of number. So for the first one, we have 1 plus 3 plus 9 plus 27, and it's infinite to 8 terms. Okay, up to 8 terms. So we are looking for SH. So Sn, okay, before we can know which of the formula of Sn to use, let's find our common ratio, which is 3 over 1, which is 3, and our first term is A. So since 3 is greater than 1, we use the formula Sn equal to A into r raised to power n minus 1 all over r minus 1. Okay, so that will give us SH equal to 1 into 3 raised to power 8 minus 1 all over 3 minus 1. So this is 3 raised to power 8 minus 1, 3 raised to power 8 is 6561 minus 1 all over 2, and this is 6560 all over 2, which is 3, 2 and 16. 2 and 16 we have 8. So SH equals to 3280. Okay, for B, for the series in B, we have 2, 10, 50, 250 up to 10. So for B we have 2, 10, 250 up to the 10 times. Okay, so our first term is A, which is 2. Then our common ratio R is 10 over 2, which is 5. Okay, let's check what we have there. Yeah, there's a 50 here before 250. So this is plus 250 plus up to 10 terms. Okay, so the number of terms we are considering is 10, and of course r is greater than 1, so we use the second formula, A into r raised to power n minus 1 all over r minus 1. So that means x10 equal to a, which is 2, multiplied by r raised to power 10, 5 raised to power 10 minus 1 over 5 minus 1. And that, of course, is equal to 2. 5 raised to power 10 is 976 9,765,625 minus 1, everything over 4. 5 minus 1 is 4, 2 here 2, so we have 9765 into 624 over 2. And if we divide this expression by 2, guys, dividing this expression by 2, we have a 4 2 in 9 is 4, 2 in 17, that is 8, 2 in 16 is 8, 2 in 5 is 2, 2 in 16 is 8, 2 into 1 and then 2. So therefore S10 equals to 4,882,812. So that is the sum of the 10 terms of that series. Now sum of we'll look at this in another lesson. See you there. Bye. Please remember to subscribe,